Hello everyone, I will tell you how I did the solution to the first assignment of the scientific programming course. I have started the course of the question we have solved here in explanation section. By the way, I skipped the question 2nd, 3rd, 4th and 6th. In the first task given, we are asked to explain the Markov Chains rule and solve a simple example. In our solution, we first add the libraries that we will use. Then we determine the states of the game, our luck, the counter required for the loop, and our luck in the ground globally, where our game happens in the while loop. Our game will continue as long as state is a number other than 0. First of all, we determine our luck. We take the value of the current round from the luck array. If the value obtained here is a greater than 10, that is the length of the chance array. We take the mode and continue. Then we create a control structure for the decrement state. If our chance is 0 here, the enters the control. If not, we increase our counter and continue. Inside the control structure, there are random values that we need to get from the dice. For this, we create the roll function above. The roll function creates and returns a random integer value between 1 and 0. We wrote the isEven function to check whether the random value is even or not. If our roll value is even, we subtract 1 from our state. If not, we increment our state value by 1. Unless, of course, our state here is greater than and equal to 10. Then we print the plate toward the console. And this completing the first part. In the second example, we start from 4 instead of 10. The only differences with the code I wrote above is the state value. Next are the transition matrix question. There is a certain rule in the question given to us. It talks about which state to go to as a result of these determined possibilities. In my solution, I first want to explain the random choice method, the NumPy library. The first parameter taken here are values. The second taken value p equals is the probabilities of these values. In the transition matrix function I created, we check if your state is greater than equal 4. Then we create an array of zeros of size n times n with the given n value. I set I for our counter, prop for probability value, and temp for temporary values. I use the prop function to fill the created array. I wrote controls for the rules given to us according to values received here. I updated the temp value in the situation that went into the controls, and we updated the elements of our array, consisting of zeros with the temp value. After we complete our array, we return our matrix. In the question file, we are asked to solve an example of Monte Carlo simulation. I need a few inputs to start the simulation. These, how many times the application will simulate, the maximum number of rolls, and the value for the bet. Then I create an empty array to track the winning odds and see our final balance. Then I create our figure and start the simulation. I start with a loop to simulate as many as the desired number in our function. I create the numWins variable to determine the number of the results we want. In my second loop, the game is played until the desired number of points. We added the roll dice function to determine the status of our dice. In this function, I check whether 2 dice are rolled and whether they are the same or not. If it is the same, we enter the first condition. Then I add the sum of 4 times its ratio with the previous element to the balance index we created, and increasing the number of status we win. If it is not the same, we subtract our ratio from the previous element of the balance sequence. We save our tracking variables and add a line to the figure we created. We start the cycle again for the desired simulation.